Hello, I'm Edward Tarte, math teacher. This is another in my series of solution videos to some of my math challenges. This is for my math challenge entitled Area of Ring. That challenge was about two circles having the same center forming around the inner circle a ring. And I said, consider a segment shown here in red that goes from one point on the large circle to another point and is tangent to the small circle, meaning it barely touches the small circle. Imagine that we take this segment, put it off to the side, and draw a circle with that segment as a diameter. The challenge is to prove that the area of this ring is the same as the area of that circle that has that segment as a diameter. Well, I'm going to figure out the area of the ring, calling the radius of the smaller circle lowercase r and the radius of the larger circle capital R. The formula for the area of a circle is pi times the radius squared, and the area of that ring is the area of the larger circle minus the area of the smaller circle. And that means the area of the ring is pi times capital R squared minus pi times lowercase r squared. I can factor out the common factor pi and write that as pi times capital R squared minus lowercase r squared. That's the area of the ring. Now I need to figure out the area of the circle that it will have that red segment as a diameter. From the point of tangency to one end is half the segment. That's a fact from geometry. Also, it's a fact from geometry that what I've shown here is a red triangle, which is a right triangle. This angle where the tangent meets that radius is a right angle. That's another fact from geometry. So we have a right triangle. I'm calling the radius, what's going to be the radius of the new circle, cursive capital R, and we're going to use the Pythagorean equation now. The Pythagorean equation says that if we have a right triangle with legs A and B and hypotenuse C, a squared plus b squared equals c squared. Applying that Pythagorean formula to this right triangle, we have these r's. Lowercase r squared plus cursive r squared equals capital R squared. Subtracting little r squared from both sides, we get this equation. Cursive r squared equals capital R squared minus little r squared. So now turning to the area of the new circle, the circle that will have that red segment as its diameter, its area is pi times cursive r squared, and making this substitution gives us the area as pi times capital R squared minus little r squared, which is the same as the area of the ring. And that's what we were supposed to prove. So that is my solution to my area of ring math challenge. Thank you for watching this solution video.